The Applied Meteorological Research Center and the Faculty of Engineering, Gifu University is currently developing the technology for analyzing typhoon movement. The technology is expected to contribute far greater accuracy in forecasting of typhoon tracks. The details on the research will be explained by Associate Professor Jun Yoshino.
Hi, my name is Jun Yoshino. I am the director of the Applied Meteorological Research Center here at the Gifu University. This is a new research center was established in 2017, comprising the 10 researchers who have been engaged in the fundamental researches and development to utilize weather information for engineering fields. In 2006, permission for operational weather forecasting was granted to us from the Japan Meteorological Agency, making us the first and only university in Japan to provide original weather forecast operationally. This has enabled us to provide on the internet daily high-resolution local weather forecasts for the Aichi and Gifu prefectures by 3 weather forecasters. Meanwhile, we are currently developing a new analysis method for the typhoon movement. Simply speaking, this method helps provide an explanation of the physical processes governing the movement of the typhoons along its observed track. While many recent typhoons have followed paths that are more erratic and less predictable, it is extremely difficult even for the weather forecasters to explain why recent typhoons move along such an unpredictable path. We believe our analysis method can offer an answer for such an important question. As shown in this video clip, a typhoon shows a swirling flow around its eye as a center, which is also surrounded by many other swirling flows around the typhoon. The surrounding vortices strongly influence the movement of the typhoon. A typhoon has a little power to move itself, but it is swept by the surrounding environmental flows like a leaf flowing through a river. Thus, we have focused on the physical quantity in the atmospheres, called potential vorticity (PV). Roughly speaking, PV is a physical variable showing the intensity and direction of a vortex in the atmospheres. Generally, a counterclockwise rotation seen in a typhoon and cyclone has a large positive PV value. PV is defined by the product of the vorticity vector and stability vector, which are composed of temperature, pressure, and wind vectors in the atmosphere. Then, there is a powerful feature in potential vorticity, from which we can inversely estimate the temperature, pressure, and wind vectors. Using these unique features of PV, we can estimate the steering flow generated by the surrounding vortices around the typhoon. As shown in the figure, the PV field is divided into the 6 types: the typhoon itself PPBT, mean flow MPB, upper level trough PPBU, low level cyclone PPBL, upper level ridge NPBU, and low level anticyclone NPBL. Comparing the 5 divided flows at the center of the typhoon can give us a physical explanations to the questions: how do the environmental vortices affect the typhoon movement? I'd like to provide one example showing the observed moving speed vectors of Typhoon Lion Rock in 2016. Typhoon Lion Rock showed a unique movement in meandering and wandering streams, which are largely different from those of the general typhoons. As a result of the unexpected erratic movement of Lion Rock along the Pacific side of Tohoku region in Japan witnessed significant flooding and landslides. Now take a look at this figure showing the estimated moving speed vectors of Typhoon Lion Rock based on our analysis method. Comparing both these figures, our method shows a good agreement with the observations and can estimate typhoon movement accurately enough to explain the reason why Lion Rock took such a strange path. These figures show the estimated steering flow divided by the 6 types of the vortices. We found that the Lion Rock's movement is strongly affected by the 3 surrounding vortices, PPBU, PPBL, and NPBU. The analysis method shown here is being introduced into the operational weather forecasts by the cooperative studies with the Japan Meteorological Agency and is expected to play an important role in enhancing the accuracy of typhoon track predictions. In recent years, extreme weather such as strong typhoons and heavy rainfalls have resulted in huge disasters and casualties around the world caused by the global warming. Accurate weather forecasting is becoming more and more essential for our lives to prevent and mitigate the weather-related disasters. Furthermore, weather information can be utilized not only for the disaster preventions, but also industrial development. Weather and climate changes also significantly affect the various industries in energy, agriculture, fishery, retail, healthcare, transportation, and so on. Our research purpose is to develop the framework for applying the accurate and valuable weather information to the various industrial fields and to contribute meaningful weather intelligence which can enable high productivity and efficiency in the local society and economies. We welcome any requests for the weather information from you.